I'm not sure why I'm smiling when I say that. That would be sad. You would die. Okay? So it's going to get a 10 on occurrence. It happens all the time. It's going to get a 10 on severity. So brakes are a bad idea, right? What do you do to make it acceptable? What do they do in a car?
Make it really easy to detect.
And what do they do to make it easy to detect? You're correct. When brakes start to wear... How many of you drive an automobile? Okay. What happens to the car when the brakes start to wear out? I really hope it's just because it's early in the morning. They start to squeak, right? They're designed to put a piece of metal in so when you hit your brakes, it starts to squeak. And the more they wear out, the louder it squeaks. It's like, oh, I think I hear something. Then it's like, it's annoying. Then it's like, anybody that rides with me is annoyed. Then a little bit later, everyone around me gets annoyed. It screams at you, change your brakes. So I know when they're wearing out. Okay? So sometimes when you're looking at a failure mode, I can't get rid of it, but I'm going to make it really easy to detect. Now, what you do is you go through and you rate these, you multiply the numbers together, you rank them, highest to lowest, and then as a design team, you go through which of these are we going to get rid of? And develop a plan for that. Now this is one of the things, and it's a great ethics thing, when you, in your design, often you can't get rid of all potential failures. And that becomes a decision as a design team. How many of the failures can you actually address with that? You want to figure out how you're going to use things. Now, this is, right, usability problems found. If I test it on every user possible, I have a really high probability of figuring out any problems. Can you test with every possible user in a real product? No. So what you're going to do is you're going to go back, and it's a decision. But how are you going to test? Some other things that you want to consider when you've got your concept are some things like in universal inclusive design. The design that we have, how inclusive is it? Is it going to exclude certain users? Is it okay to exclude certain users from what our product design is, and also from a broader an equity type issue? So I've got friends that use wheelchairs. And when I talk to them, they talk about there's still a lot of things that are designed that don't think of them. So as a designer, can I go through and I say, okay, before we finish the product, can we think about who might be using it? And here's some universal design principles that I want to go through real fast. And I'm going to pause just a second because I don't have the attendance forms. And this is actually going to be on film, which is slightly embarrassing. But use. Is anybody on Camp Riley team? So one of our teams is paired up with Camp Riley that's an accessible camp, summer camp. And it's kind of interesting that if you go like to Elliott Hall of Music and you use a wheelchair, there's a certain place you have to sit. You go to this camp, use a wheelchair, you can sit anywhere because every spot is accessible, and if I don't use a wheelchair, I just put the seat down and I can sit in that. Fundamentally, not a lot of difference. They just don't have the permanent armrests. Okay? Can I, flexibility in use. Okay? Can I look at things like right-handed or left-handed? Do you know left-handed people in the United States have a lower life expectancy? Actually, globally. Primary reason is there's so many things that are designed for right-handed people, it's more likely a left-handed person is going to have an accident. That seems kind of dumb, right? So a lot of things, it's like, okay, can I think about this if it was used with the other piece? Simple and intuitive uses. Why does that sign have to say push? Right? Now, if you have a sense of humor, you're like, oh, yeah, I intended to do that. But when you look at something to say, is it easy to use? When we used to design things in aerospace, we'd say, okay, does it make sense how to use something? Communicate perceptible information. Can I communicate necessary information regardless of the conditions or people's, we say, sensory abilities? You know, nowadays you buy a product and you get this documentation, all the instructions. I'm sure everybody fully reads all the instructions. You know, can I get things? Are there different modes of communication? You know, one of the things, if you go out to the crosswalk out here, they're starting to see, crosswalk goes on. I can have multiple ways to say the crosswalk's on. So they've got the lights, they've got the countdown thing, which I really love, because then you're like, 7 seconds, I think I can sprint across. And then they're also counting it down audibly, so if I can't see, I can also hear. Lights, color schemes, tolerance for error, minimizing errors. When we used to design, there'd be an exercise we'd have to go through and ask, could the parts we were designing be put together incorrectly? And I saw one presentation where there was a young engineer, and I was so glad it was not me. Because they're an experienced manager, and he laid a trap for this designer. And the designer fell in to the trap. Person said, could this part be assembled incorrectly? And the designer went and said, you'd have to be a total idiot to do that. And the manager said, so the answer is yes, it could. He said, you'd have to make so many mistakes. So the man, and now recognize, I worked in aerospace. So our tolerance for, if it could, something cannot be put together incorrectly and assembled on a plane, the risk is too high. So the manager said, so it is possible. He goes, well, you'd have to do all these things. He said, we're done. Fix it. Manager walked out. Because we could not, thank you, promised to have it at 4:30. I'm on a string for getting the forms. So when you look at tolerance for errors, it's real common for designers to blame the users. Well, if they were just as smart as us, they wouldn't make these mistakes. Warning things. You know, when you look at something to say, if something's going to happen wrong, can you go back? You know, before you delete something, does it come out to say, are you sure? Can you put something in upside down? There's a book a colleague pointed me to, and the point of the book is failure modes, design mistakes. And in each chapter, it talks about a product and somebody dies. My colleague was like, yeah, it's a really cool book. I'm like, that's sick. But it's about things like, you know, one of the things was in a hospital, they saved money by having the same connectors for every kind of thing. So the power, 120 volts, was the same connector that hooked up like the instruments that went to the body. And so the mistake that killed the patient is they put 120 volts directly into the patient. That's not funny. Those of you on film, there are people that kind of like, okay, whatever. Okay? But you look at that and say, okay, it might cost a little bit more, but what's the failure? Have you noticed red lights are always at the top? Why is that important? Does it have to be? You could always spot the red light, right? As long as you can see color. If I'm colorblind, I don't see red and green. I look for what? If a traffic light's horizontal, is the red light on the left or right? I honestly don't remember. But I've got a friend whose child is colorblind. First time they took the car up in Chicago, there are places where the lights are horizontal. I'm like, is the red light on the left or right? Kind of makes a difference. Okay, so there's consistency as part of inclusion. How much effort is used? We had a team that said, you know what, we went out, we got ergonomic data, and 50% of the general population can lift our device. What percent of the population couldn't use their device? 50%. By the way, they were designing it for Head Start. They were using average population strength. The entire population, or all the instructors were female. The average strength of a woman is going to be less than a man, so it's actually more than 50% of the people who were going to use it couldn't use it. Made sense, but they didn't ask on how many can't. And when I come out, there are a lot of things that when you get things to say, what if somebody has arthritis or something? What if they can't? These are things you want to decide. How inclusive can you make it? The size, body size. You know, when they first came out with airbags, they did a lot of damage to people because they were designed to stop I can't remember if it's like 6 foot, 6'2", 220-pound person who was not buckled. And it was aimed, the original designs came out at you and aimed for your upper chest. When I think of my grandmother, she used to look, it was hard to tell, like when she'd go by, you'd think nobody was in the car because she would look between the steering wheel and the dashboard. So that airbag would have been aimed right at the top of her head. Would not have saved her life, would have broken her neck. So these are things to look at. So there are ADA guidelines. If you're looking at things to say if somebody has a wheelchair, we do have a wheelchair in the lab, so you can even get out and look at some of those. There's anthropomorphic data. 2 last things on the delivery phase. Once you get the design finished, you need to make it ready for the partner to have. We have a policy that you should try to deliver in week 12 or sooner. You can get permission to deliver later, but we don't. Our partners have asked not to deliver it during finals week. Why? The answer is, what if something goes wrong? They're stuck with it. They want you to deliver it with time that you can help work with things. We have a design process. There's a delivery process checklist. The liability issues with so Purdue covers the liability of our products with the understanding that it follows our process. Every project needs to follow our process. So it goes through the design reviews, goes through your advisor approval, partner approval, and then it has one final check by somebody in the EPICS administration. Myself, Andrew Pierce, somebody like that. Also, if you follow this, there are these cool shirts that you get for delivery. Okay? And there's some projects that have been delivered a few times. Final thought, the maintenance and service. We make an agreement with our partners to be partners with them in the entire process. That includes the service and maintenance. That does not mean you all have to maintain every part of the project for the entire life of the project. What it should mean is that you have a discussion with your partner about how the project's going to be maintained and who's responsible for what. It may mean, for those of you on teams that have been around a while, that you're going to have to do some field work on some existing delivered projects. So your team has a responsibility for the projects you're working on, as well as any other projects that have been delivered to your team. I might have, okay? And what we generally agree to, so when I say agree to things, you want to figure out what the capabilities of your team are. Will you pass it back to those two? You want to have your name and your student ID on there for the forms. This agreement, and this is very important, this part of the agreement should have been discussed at the beginning of the project. Back in problem identification, to agree to say, okay, when we do this, who's going to handle which parts? And during the design, hopefully you've thought about who's going to maintain the stuff and what are they going to need. And the last phase, and you actually see some of the projects that we brought back. Part of sustainable design is thinking about what's going to happen to your project when it's done with its life. We have a general agreement with our partners that we will partner with them to figure out what to do. Sometimes that means bringing the project back here, figuring out what to do, taking things off that could be recycled, and disposing of other things. So that is an expectation for us. What I'm going to do next week is we're going to talk about some design tools and some way of thinking about design. I've talked about the design process, and I've talked about it as kind of a linear process. We're going to talk about some characteristics of being good designers and some tools that you can have, okay? For those of you in person, you want to put true for number 1, and we'll collect the forms. For those of you online, you're going to go to the My EPICS system, and you're going to list 3 things that you've learned. There's not a specific homework, but I do encourage all of you, whether you're online or here, to be writing a reflection based on the content of this, where your project is and how these apply, and that shows up in your notebook, because one of the things you're evaluated on is your critical thinking. If you've not read the design process document, please go through and read that. At least scan the parts that had been done in your project, and read some of the tools. There are more details on the tools that we did here. Okay? Those of you that are here, if you leave your attendance things on a table up there, I will collect them and get them up.